Welcome back, everyone. Today we will be going over the basics of neural networks. Let's start with a brief description. Neural networks are a class of machine learning models inspired by the structure and function of the human brain. They consist of interconnected nodes called neurons, which are organized into layers. These networks are capable of learning complex patterns and making predictions based on data. Now let's look at the basic structure of these neural networks, starting with the neuron. Neurons are the fundamental units of a neural network. They are inspired by the neurons in the human brain and are responsible for processing and transmitting information. Neurons are also organized into layers within a neural network. Let's take a look at these layers next. So, as mentioned on the previous slide, neurons are organized into layers. Each layer has a specific role. The first layer is the input layer, which is the first layer. The first layer is the input layer. It will receive raw input data, which could be something like an image or numerical data. Each neuron in the input layer represents a feature of the input data. Each neuron in the input layer represents a feature of the input data. The next layers are hidden layers. These are intermediate layers between the input and output layers. They are responsible for processing and transforming the input patterns. These are called deep neural networks. Each neuron in a hidden layer performs a weighted sum of its inputs, adds a bias, and applies an activation function. We will return back to these terms later. The last layer is the final layer of the network. It produces the output of the network, which could be something like a classification label or a regression value. The number of neurons in the output layer corresponds to the number of possible outputs. Earlier we mentioned connections and biases when we were talking about hidden layers. What do these actually mean? Let's start with connections. Connections in a neural network refer to neurons in adjacent layers, which are connected by weighted links. These weights determine the strength and direction of the influence between neurons. Now let's look at bias. Each neuron, except for those in the input layer, has an additional parameter called bias. The bias allows the activation function to be shifted, enabling better fitting of the data. Training a model involves adjusting the weights and biases to minimize error in the network's predictions. We've mentioned activation functions many times, so let's talk about what they are. In simple terms, activation functions introduce non-linearity into the network, allowing it to learn more complex patterns. Here I have included some common activation functions used in neural networks. The first one is the sigmoid function, which outputs a value between 0 and 1. The second function here is the tanh or hyperbolic tangent function, which outputs a value between negative 0. The second function here is a tanh or hyperbolic tangent. The second function here is the tanh or hyperbolic tangent function, which outputs a value between negative 1 and 1. The last one I have included here is the rectified linear unit function, which outputs 0 if the input is negative and the input itself if it's positive. That's all we have time for today. In the next video, we will go more in depth about training a neural network and learn some. That's all we have time for today. In the next video, we will go over. Jesus Christ. That's all we have time for today. In the next video, we will go more in depth about training a neural network and learn some new terms like forward passes, backpropagation, and loss functions. Thanks for watching.